The three big problems I see when people use Git are resolving merge conflicts, removing commits that contain secrets or third-party assets, and disaster recovery when people think they've ruined everything and just need to start all over. We're going to look at solving all three of those problems today. Being able to use Git like a pro is a skill that will serve you for your entire career. Most people never learn it, and if you invest the time, you'll be the one that everyone on the team comes to when they're in a jam. So today I'm going to show you how I use Git and as many secrets as I can in the next 25 minutes or so. Let's start by creating a repository. The first thing I want to do is come over to Git and just create a repository for this video. I'm just going to call it demo, and I'm going to click create and jump over to the instructions page. Sometimes I'll copy and paste this because I don't want to make a mistake typing in the URL for this repository. Now, I'm going to have a little diagram here up on the screen as we move through the different operations. We've initialized our remotes, so I'm going to mark that black. Then I'm going to open up Git Bash so that we can start working from the command line. The first thing I want to do is just output where my home folder is, and that's because I want to have a look at our global.gitconfig file first. I'm going to grab mine and open it up in Rider. The most important thing in this file is actually all of my aliases. So I have shorthand commands for all of the usual suspects like commit, status, branch, diff, and so on. We're probably going to end up using all of these commands today. So let's come back to the command line and actually create our local repo. Next, we can add the connection to our remote using the git remote command. Now you could just paste this in from those instructions earlier, or just type it out like so. There's no real confirmation after I click enter here, however, but you can always verify your connection by typing git remote-v. Now, when you do this, you're going to see two entries, and that's because it is possible in Git to have a different URL for retrieval than it is for the one that you're pushing to. But in most cases, they're probably going to be the same. Anytime you're not sure of what's going on currently, just type git status or git st is my shortcut for that. You can see I haven't actually checked in anything. Everything has question marks beside it. The two question marks beside a file means that it's not being tracked by Git yet. I'm also going to create an empty README file here just so that we have one more file to work with during our commits and changes and conflicts and whatnot. So now if I type git st or git status again, we'll see that the README is included in the untracked files. Now I want to make my first commit. I probably want to check in everything, and the easy way to do that is with git add period. Now when you use the period, that means everything. All untracked files, all folders, all subdirectories. So that means unless it's in your git ignore, it's going to be included. If I bring up my local git ignore here, I want to point out one thing that I've got here on line 16 and 17. I've got some lines that say to ignore everything under my assets folder except the underscore project folder. So the files that I've made, my art, my work, goes in the underscore project folder. Everything else, paid assets and whatnot, is going to be ignored. Now, depending on your project setup, you might want to come in here and accommodate that a little bit to save yourself the grief of realizing later on that you put paid assets into your public repository. So let's come back out to the command line here. During the video today, you're going to see me type clear quite a bit. The clear command is a shell command that just lets me clear the terminal and start clear up from the top again. It'll make it easier to see everything. So now if I execute git add period, it'll grab everything that wasn't in the ignore list and stage it for our commit. If I type git status again, I'll be able to see exactly what is being staged. If I type out the entire command, git status with a -sb, that means short form, and b means it's going to show some branch information at the very top. But I have this already as an alias as git st, so let's type that and just see exactly what we've got staged here. On your first commit, it's a good idea to kind of comb through here and just have a good look, make sure there's nothing strange going on, make sure it has all the files you expect to be in your first commit. Now, this is exactly what I expect to see, so I'm going to come back to the command line here and make my first commit. You can make one-line commits without opening an editor with the -m command and just have a short message here. Recall that I have an alias, CI is short for commit or check-in. Now we've got our first commit. Let's see where we're at. If I type git st again, we'll see there's nothing staged anymore. And if I type in git lg, which is my shortcut for my pretty log, we'll see that we have one commit on master. We can also push this first commit up to the remote with git push -u origin head. And the -u here means that we're going to set the upstream. This means that future commands like git pull, git push, git status on this branch will automatically know which remote branch to reference without needing to specify it explicitly. Now, in my little diagram there, you'll see we now have identical commits on the local and the remote. Now, I think I'll change the commit names to actually say what branch we're on because we're about to make a new branch. Usually when I'm making a new branch, I'll use git checkout -b and then the name of my new branch. And what that does is creates the branch and checks that branch out in one command. So now that we're on a new branch, let's make some changes to a file in the project. First of all, let's make the speed property private, and I'm going to remove this debug statement. So let's come back to the command line and see what's going on. So we have one file that has been modified. Let's add that with a git add -u. -u stands for update. That'll get any modified or deleted files, but it does not include new files. We can check that quickly to make sure it was staged. And now we can make a commit. I'm just going to add that commit to the diagram. And then let's type git lg for log again. And we can see that we have our two commits on this branch now going all the way back to the commit that we started this branch from. Let's quickly create one more commit by editing the README file just so that we have one more commit here to work with. I'm just going to keep this super simple, just a title and one little sentence. That'll be enough for our purposes. If you're in Rider, you can add a file to be staged with Control-Alt-A. We can see that if we come out to the command line and hit git st. There we go. README's already marked green. It's ready to go. But let's talk about git reset for a second. Git reset by itself defaults to mixed. And that means it will unstage all your changes, but it doesn't throw your changes away. Git reset soft will move to a commit, but leave your staged files the way they were. Git reset hard will move to a commit, but it will throw out all your changes. It discards them. Let's just see that in action quickly. So a git reset soft here actually won't do anything. If I type git st, you'll see my README is still staged. I could have moved to another commit, but I just moved to this same commit. If I just type git reset by itself, that's the same as mixed. And now it says to me it has unstaged my changes. And if we type git st, you can see that file's unstaged. I want to show one other method of adding files here. If we type git add --interactive, Git has a little interactive mode here, and you can choose status, update, revert, etc. So if I choose 2 for update, I can then choose any of these unstaged files and add them. So I'm going to choose 1. Then if I hit enter again, it'll get me out of update mode. And then I can hit Q to totally get out of interactive mode. Typing git st at this point will show us that yes, README has been staged again. So that's a little known feature of Git. I just thought I'd point that out for anybody that's interested in using it that way. Let's go ahead and make the next commit on our feature branch. Let's make sure my diagram's updated to here with the next commit and its ID. Every once in a while, I like to do a git log just for a little sanity check and make sure I know what I'm doing, make sure that everything looks the way I expect. And of course it does. We can see master and origin master are still back at the initial commit, and we've made 2 new commits in our branch. I'm going to modify one more file just so we have a third commit here. I'll go into my input reader and I'll just put one of these properties to be public. And I think that's enough for us to get one file into another commit. I haven't actually pushed this feature branch up to the remote yet, so why don't I do that really quick? We can just do a git push -u origin head. That'll set up our upstream branch and get everything set up on the remote before we do any more work. So with that push, my feature branch on my local and my remote match exactly. But now let's add this input reader on the local. We'll make one more commit here. I'll just make a simple message for that. Just before we start introducing conflicts that we need to resolve, I just want to show one more command here quickly, and that is, how do you see the difference between where we are right now and what's on the remote? If I type git diff at curly brackets u, that is the difference between me right now on the local and the upstream. Right now, there's only one commit difference, and you can see the change that I made in the input reader class. Again, I'll just update my diagram here with that new commit on the local. Now, another really handy thing you might want to do is see the full history of any given file, all the changes, every single commit where it was possibly changed. Let's do that with the hero class. So you can see I made changes to the hero class 2 times. Of course, there's the initial commit when we checked it in, but then I changed it again when I made the speed property private. Okay, let's move on to conflict resolution. I'm going to check out master and I'm going to create a problem. So normally, if you were working on a team, or even sometimes when you're working by yourself, you may have made changes to the same file in multiple branches, and that's where you start to have problems. Back here on the master branch, if I come into the hero class and I change this public property, even just a little bit like this, now we have a conflict between my feature branch and this branch, if I were to check this in. I'm also going to delete that comment just so we can see this very clearly. So back here on the command line, we can see that we've made changes to the hero class. So why don't we add this and we can check it in a new commit here. So now we've got 2 commits on the master branch. Let's do a git log and just have a look at that quickly. So our head is now at the tip of master and we have 2 commits on there. But we know there's a problem because the hero class is different in master than it is at the tip of our feature branch. Now, I know this is where a lot of people get stuck, so we're going to walk through this together. Before we get to that, I'm just going to push quickly so that my remote is the same as my local. There we go. Now, before doing any merges, rebases, or anything like that, always do a git fetch. Git fetch will download the refs from your remote repository without merging them into the current branch. This is especially important when you're working on teams and other people have been merging branches in. You want to always have the latest. Now let's check out my feature and see what kind of problems we can run into. Right away, Git is telling me that I'm behind on my remote. So let's do a push quickly. It's not mission critical because we're going to do everything from the command line, but if you wanted to be doing your merges from GitHub, for example, or you have people doing code review and you're going to open a pull request, although normally I would squash my entire feature branch before opening a PR. The only time I wouldn't squash a PR is if I wanted the reviewers to be able to see all the steps that I went through to get to the final point. The other thing I always do before I start a potentially dangerous operation is I take note of the commit that I'm on, because we can always get back to this commit. One way to easily get the commit is just to do a git rev parse that will output this commit, and you only need the short version of it. Copy paste that somewhere into Notepad or something. With that information, at any point you feel like things are getting out of control, you can just abort the operation that you're in the middle of and do a hard reset back to that commit. Then you can just start over. Now here, I don't want to just do a merge into master. What I really want is for my feature to be at the very top of my master branch, and I want to squash all of my commits. So what I'm going to do is a git rebase -i onto master. -i means interactive. That means it's going to bring up a window for me to make some choices in. And for me right now, I have that set up to use VS Code. Because I'm doing an interactive rebase, it's going to ask me which of these commits I want to keep. You can squash all of them except the first one. So you can use the shorthand S, or you can actually type out squash if you want. And this is going to reduce those 3 commits into 1 new commit. Of course, when I come out of there, it's going to continue my rebase and tell me, hey, we have a conflict in the hero class. Of course, we knew that was going to happen. So what do we do about it? Well, you can fix them all by hand, or you can use a merge tool. So I've got one configured here. If I just type git merge tool, it's going to open it up, and let me show you what it is. So the tool that I use at home and at work is called Meld, and I use this on Windows and on Linux. If we come to meldmerge.org and just scroll down a little bit, you can see we've got a Windows MSI downloader here. So you can download this and install it on your system. And let's quickly also take a look at my git config, because if we come down to the bottom here and have a look at where I've specified my merge settings, so you can see I've got quite a few settings here for it that are good defaults. And then I've also got the path right to the app. So when I type git merge tool, this is what gets run. So let's come back to the command line and actually execute it. This would actually walk through every single file that's a conflict in this particular step of the rebase. We only have one, it's the hero. It'll show that here on the console while it's bringing up my merge tool. So let's have a closer look at what's going on here. If we take a look, there's 3 panes. You can see on the left here, we've got one that says local. We've got one on the far right that says remote, and we've got one in the middle. And this is the one that's going to be the resolution of the 2 sides. So on the right side, you can see I've got the more complex speed property. The one on the left has our simplified property. And the one in the middle is actually coming from our first common ancestor, which is actually our initial commit. Both the master and our feature branch deviated from that original point. So what do we do in here? There's some little helpers. If you notice these arrows, they let us quickly move a conflict into the middle or out of the middle if we don't want it anymore. So maybe we don't want that debug statement anymore, but I want that speed property from the right side. So I click the arrow, it comes over. You can see it's not red anymore. I'm going to click Control S to save my middle pane there, and I'm going to close this app and move on. Now, the next step in this is it's going to ask me if I'm happy or not. It's staged the file. If I'm happy, I can just continue the rebase. Continuing the rebase at this point is going to prompt me about this particular commit message. So we can jump over into VS Code here, and you can change it or not. We're going to continue squashing things, so it doesn't matter too much. With the message done, we can close this up, and it'll just continue asking us what we want to do with all three of these commits now. So you see, it has got my new message there, but it doesn't matter too much, because here you also have the opportunity to say, what do I want my final commit to be now that all three of these have resolved all the conflicts and squashed together? So I'm going to say, we've adjusted the speed property, the README, and the input reader. In a real scenario, I'd probably say more than this, but that's a good title for now and just for this demo. So we close it up, and guess what? We're done the rebase. So what does it look like right now? Let's have a look. I'm going to do a git log and also bring back my diagram to show that we've squashed all those commits in the feature branch down into one. And you can see it even has a new ID there at the top. So we've got our initial commit, and then our hero changes in master. Those are both commits in master branch. And now my squashed commit right on top of them. Now we're free to merge in this feature right to the top of master. If I check out master and I merge in the feature, watch what happens if I type git log on the master branch. Now we can see that head is pointing to the tip of master and the tip of my feature branch, and we've successfully merged the feature right to the top of master. Normally at this point, I would probably push this up to master because I've resolved all the conflicts and my master branch should be nice and happy. However, I'm going to reset a few things just back in time a little bit so I can show you another way to resolve conflicts. So I've done a bit of Git time traveling, and I've gone back to the state we were in right before we started conflict resolution. If we look at those logs really quick, we see we still have those three commits that I made in the feature branch, and my master branch just has the conflict change and the initial commit. With this next way of resolving conflicts, we're going to start from the feature branch. So before, we were rebasing our commit onto master. This time I'm going to merge master into my feature. Now, just before I start resolving this conflict, I'm going to do one thing, and I really wanted to show this because this trips a lot of people up. Git has a system called re, and that's short for reuse recorded resolution. So when I solved the resolution of the conflicts in the hero class before, it recorded that resolution. And if I try and solve it again now, it's just going to automatically apply that resolution, and that may or may not be what I want. More often than not, you're going to need to do this because it means that you've made a mistake and you're starting over. So let's merge master into this branch. You can see right away, I've got a conflict. So we know what to do. Let's open the merge tool. Now you might notice something a little bit different this time, and that's because I'm going the other way. I'm merging master into my feature instead of my feature into master. So the change I want is actually on the left side this time. So I'm just going to bring that in. This time, just for interest's sake, I'm going to delete the debug statement and then save, close this up. Now that I've solved all the conflicts, I can continue my merge, and it's going to prompt me to give this merge commit some kind of special name. I always just leave it. It lets me know what I just did. I merged master into the feature, and we're done. We now have a new little commit on our branch. Let's have a look at that quickly. Since I've now merged these two branches together at that point, we have a new commit that actually both of these branches point to. So I put that up at the very top of my chart here, and I'm going to draw an arrow from each branch to point into that just to show what's going on there. The next thing I'm going to do is do a hard reset on master. Notice that right now the tip of master is pointing at that second commit on the master branch. I'm going to move the head on my diagram to indicate that. Now I can do a merge squash, and I'm going to combine all the changes from the previous state of the current branch into a single commit. And that's what head at curly brackets 1 means. The state of this branch one step before we were right now. In our diagram, that was everything traveling up the right side. So now that we've squashed everything, we actually need to put it into its new commit. You see, we don't have a commit yet on this branch, but there are staged files. So all we really need to do is do a git commit, and I'm going to open up VS Code and add a message for that. So here we can see all 4 of the commits that we squashed, which includes merging master into the feature and resolving all the conflicts. Now, I realize this second way of resolving conflicts maybe seems a little bit complicated, but I prefer it because I'm not getting stopped every 1, 2, or 5 commits to resolve some problem as it tries to squash everything down one by one. Instead, what I'm doing is bringing master into the top, solving the problems one time, and then squashing everything. So if we output the log right now, we'll see that on our feature branch, we only have 3 commits now, and master is just 1 commit behind us. Now let's get all the branches up to date, including the remotes. So I've squashed everything up on my feature. Let's force push that up so that the remote matches my work on the local machine. Since the remote doesn't match my local anymore, I need to use a -F for a force push. That'll overwrite what's going on in the remote, so be careful with the -F. Then we can check out master and merge the feature into master. Let's do a git lg and just see where we're at. Okay, so everything is at the very tip of our topmost commit except origin master. Now, origin master is only 1 commit behind, and we've never pushed to remote past that. So all we have to do is a git push, and then everything is up to speed. Let's just verify that one more time by looking at the log, and sure enough, you can see head points to master, origin feature, and our local feature. I think that's enough conflict resolution. How about we look at getting rid of secrets? I'm going to put a few secrets into the hero class here, things that you should never commit into your repository. So what would we do about this if you accidentally did such a thing? Well, first of all, let's verify that we've made a change, and sure enough, there's something to be checked in. So let's just commit it for now, and then we'll see what we can do about it. So if we just make a simple commit here that says added secret, okay, we've got our commit there. It's at the head of master branch. We haven't pushed it to the remote. So the easy thing to do, especially because we haven't pushed anything, is we can do a hard reset 1 commit before this one, and that is head ~1. You can go back even further than that if you use 2, 3, or 4, however many commits back you want to go. Now, that way works fine if you want to throw out the entire commit, but what if you have other things in that commit that you want to keep? Well, let's come in here and just fix these secrets, and then what we can do is use git-amend. Git-amend is a way of committing things over top of an existing commit. It's going to give you a new commit ID, but it will rewrite the history of that commit. So now we can do git commit --amend, and I'm going to add --no edit, which means I don't want to change the commit message. Now, if we look here, it's just overwritten my commit with a new commit ID. Maybe I should have changed the message because there isn't a secret there anymore. We can verify that by doing a git diff to show the difference between the parent of the current commit and the current commit itself. So you can see instead of having our actual secrets in there, we now have these placeholders. Now, what could you do if you have, say you've committed proprietary code, such as you made a commit where you checked in a bunch of store assets and you put them in your remote? Well, that's a bigger problem to solve. And one way that you can do it is by doing a rebase onto. So let's suppose for the sake of this example, in my second commit in this branch, the master branch, I checked in some kind of asset from the store. I need to get rid of it. So think of these commits as kind of links in the chain. Right now we've got 4 of them. I want to get rid of the second one. So I need the third one to link to the first one and kind of leave the second one off in no man's land. Git garbage collection can clean it up later. So we can accomplish this with git rebase onto --onto. Then we have to say what the new base of our commit is and what the old base was. So we're going to take that commit that starts with A8B and we're going to rebase it. So the old base of A8B was 80A. We want it to go on to 078 commit. So the structure of this command is onto the new base and then the old base. Now, of course, when I execute this, we're going to have conflicts. But we know how to deal with this by now, right? Let's open up the handy merge tool and see what's going on. So this is the same problem we had before, but it's actually between different commits this time. So let's choose a resolution for this conflict and save, and then we can close this up and move on. Now that we've solved that, we can continue our rebase. And it's going to ask us if we want to change that commit name. So this was commit number 3. You can give it another name if you want to. Obviously, I had a typo there, so I'm just going to fix it. And let's close that up. And we have success. So let's see what we're at right now. The goal was to get rid of that second commit. And there you go. It's gone. We go straight from initial commit right up to that third commit, which was the changes to the speed property. And everything that existed in that second commit is gone. However, it's not gone from our remote repository if we had pushed it there. So we can do a force push, and that will overwrite what's in the remote. However, you still have a few problems to contend with. First of all, GitHub caches things. Now you can write them an email and ask them to wipe it out. That's one thing. But the other thing is, if somebody's cloned your repository, you can't stop them now. They have a copy of all of those commits. And my advice to you is, if you put secrets in your remote repository, you have to change them. You have to change your API keys and change your passwords. If you put third-party assets in there, that's regrettable. You should change it and fix it now, and definitely be more careful in the future, because if the owners, the creators of those paid assets find out, it's not going to end well. Just make sure that never happens. Okay, last thing for today, disaster recovery. This is the most powerful Git command of all, git reflog. A lot of beginners don't realize that you can see every single move you've ever made in a repository. Git reflog will show you that. I'm just going to drag it down a little bit so we can see every single thing that I've done here today in this repository. So just for interest's sake, let's pick one commit. You can use either the head notation, head at a certain point in time, or you can use the actual ID of the reflog. Because it's fresh in our memory, I'm going to use the commit where we actually added the secret. So I'll jump back there and have a look at the log. And sure enough, we have traveled back in time to the point where we added that secret into the repository. So that's how you can disaster recover from just about anything. Barring you throwing your laptop in the garbage and deleting your GitHub, you can recover from just about any problem. To be honest, I could probably keep talking about Git for another 3 or 4 hours. There's just so much to cover and so many scenarios you could get yourself into. I think though, if you can take to heart what you've seen in this video today, it's a very, very good start on your way to becoming a Git master. There's just one thing left to say, and that is Git's not going to work for you if you don't commit. So follow the #1 rule of Git: commit early, commit often. Thanks for watching. I'll see you in the comments below, or maybe on Discord.